My name is Colin O'Keefe, and we are going to talk about sequences and series today. Alright, so for the first thing you need to know about sequences and series is the vocab. A sequence is a list of numbers in a specific order, such as the Fibonacci sequence, which is 1, 1, 2, 3, 5, 8, so on and so on. And a series is the sum of a certain amount of terms in a sequence. So like if you have 1, 2, 3, and 4 in a sequence, it would be 1 plus 2 plus 3 plus 4. And that's your series. More vocab words that you might need to know when working with sequences and series are terms, which is all the numbers in a list. General terms, which is the nth amount of term, or UN, U sub n. Another word is arithmetic sequence, which I will be using a lot in this video, which is where you add a constant. The next sequence there is a geometric sequence, which is where you multiply by a constant. All these vocab words will help you learning sequences and series. Alright, so before starting some example problems, we're going to talk about the formulas of sequences and series. So for an arithmetic sequence, the first formula is right here, and that's when you want to find an nth amount of terms in a sequence. So like if you want to find the 100th term of a sequence, it would be u sub 100, and then you put in all the other factors of it. And then if you want to find the sum for an n amount of terms in a sequence, or a whole sequence, you would use this formula to do that. So you can either use the first formula n over 2 times sub 1 plus n minus 1 d, or you can use the shorter version to figure out the sum of a sequence. So the next sequence is geometric sequence, and the first formula I have for you is will help you find the nth term in a sequence. Just like that one is to find the nth term in a sequence, this is how you can find the nth term in a geometric sequence. And just like the arithmetic sequence, it also has a formula to find the sum of a sequence. So if you use this equation, you'll find the total sum of that number sequence. And this last formula is when you're working with infinity, which is trying to figure out the infinite sum of a sequence. So this would be u sub infinity equals u sub 1 over 1 minus r, and that should get you the sum of the infinite amount in that sequence. Alright, so now let's get into the sequences. So the first sequence we're going to go through is an arithmetic sequence. So an example of a question you might find is find the 35th term of the sequence 3, 9, 15, 21. So the first thing you do is write down what you know. And the first thing that I did was I know that u sub 1 is 3. That's the first term that you have. And normally you're going to be given the first term unless the problem says you're going to get start from u sub 3 or u sub 4. But right now it doesn't tell us that it doesn't start with u sub 1, so we're going to say that 3 is u sub 1. And d, which is the difference, we just take this term and subtract it with this term, and you get 6, and 6 would be your difference. And then what the u sub n, or what n equals, we're trying to figure out, and n is the 35th term, so u sub 35 is what we want to figure out in this problem. So right now we're going to use the first formula we got when it's finding the nth term in a sequence, which is u sub n equals u sub 1 plus parentheses n minus 1 d. So we plug in everything we have. We have u sub 35 equals 3, which is our first term, parentheses 35, which is our n, minus 1, times our difference, which is 6. And if you do the math, this should equal out to 204 plus 3, and if you add those together you get 207, and that's all you have to do. U sub 35 equals 207. So that's just one way to figure out the 35th term of the sequence. Okay, so here's another example of an arithmetic sequence where you have to find an n number of terms. So the problem is find the 125th term of the sequence 4, negative 1, negative 6, negative 11. So right now you need to find your difference. And the difference in this sequence is negative 5. So you subtract 5 from 4 to get negative 1, subtract 5 from that to get negative 6, subtract 5 from that to get negative 11. And then the next thing you do is fill out what you have. So you know the u sub 1 is 4, because that's what you're given. The difference is negative 5, which we found before. And then the un, or the nth term that we're trying to find out, is 125. And now using the equation to find the n number of term is u sub n right there. And we plug in everything we know. U sub 125 equals 4 plus parentheses 125 minus 1 multiplied by a difference, negative 5. So then you get 124 times negative 5, which is 620, negative 620, plus 4, you get negative 616, and that's your answer for the u sub 125. So your 125th term of this sequence will equal negative 616. Alright, so now we're going to go on to the sum of a number of terms in a sequence. Okay, so now we're going to figure out how to find the sum of an nth amount of terms in a sequence. An arithmetic sequence, to be exact. So this problem is find the sum of the first 20 terms of an arithmetic sequence if u sub 1 is 5 and u sub 20 is 62. So by using the formula for finding the s amount of terms, or the sum about how many terms is in the sequence, you have to plug in everything we know. So use the s of n. N is our u sub 20, so that's 20. 20 goes right here because that's our n term. 5 is our u sub 1, and 62 is our u sub 20. And we filled everything out, so we just solve it like a regular equation. If you do the numerator first, you get 1340, and then if you simplify that, because it's divided by 2, you get 670. And the sum of the first 20 terms in this series is 670. It's not that difficult if you plug in everything you know into the formula given. Okay, here's another arithmetic sequence where we have to find the first amount of terms in it, and in this case it's to find the first 40 terms of the sequence 2, 5, 8, and 11. And so in this case we're not given the 40th term, so we have to figure that out by ourselves. And to do that we do the first formula we learned, which is finding the nth term in a sequence. So we're trying to find the u sub 40, so which we plug in everything we know. The first term is 2. The difference, we figured it out, is 3. So if you find the difference, 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 3 is 11, so on and so forth. So we're plugging n, which is 40, subtract it by 1, parentheses our difference, which is 3. Do all the math, and it should equal 119. And after you figure that out, we could figure out how to find the sum of the first 40 terms. So we plug in 40 for n here, and then u sub 1, which is 2, and then u sub 40, which we figured out right here, which is 119, divided by 2. Do all the math, and you get the sum of the first 40 terms equals 2,420. And now we're going to be moving on to geometric sequences. So now we moved on to geometric sequences. And right now the first thing we're going to do is find an nth amount of term in a sequence. So find the 10th term in the sequence 10, 30, 90, 270. So the first thing we have to do is find things that we know. So we know what the first number is in the sequence, which is 10. That's our u sub 1. And r in geometric sequences mean the common ratio instead of arithmetic, which is the common difference. So the common ratio, you would have to take this number and divide it by that number, or vice versa, or you can do this one to this one, and that's how you get your 3. So 90 divided by 30 is 3, which is also, some people can call it your scalar factor. So now we have to use the formula we learned in the beginning and for finding an nth amount of terms in a geometric sequence. So that's what this formula is. Now we plug in everything we know. We're trying to find the 10th term of the sequence, so it would be u sub 10 equals u sub 1, which is 10, times our common ratio, which is 3, over, or to the power of 10, which is our n, minus 1. And now, to simplify it, you get 10 times 3 to the 9th power. And if you do all the math right there, you should get 196,830 as your 10th term. We're going to do one more of these and then go into the next. Okay, so our next example of a geometric sequence where we have to find an nth term in a sequence is find the 20th term in the sequence 1, 2, 4, and 8. Alright, so now we need to figure out what we know. We know u sub 1 is 1, and we know that our common ratio is 2 because if we take the u sub 2 over u sub 1, you get 2, or u sub 3 over u sub 2, you get 2. So that's how you get your common ratio is 2. And now we plug in all of the numbers into the formula of a geometric sequence of the nth term. So that is, plug in 20 for n, because that's what we're trying to find, the 20th term, equals u sub 1, which is 1, common ratio, which is 2, and then it would be 20 minus 1, which is 19, and do the math, and then u sub 20 equals 524,288. So that's our 20th term in the sequence. Okay, so now we're going to talk about how to find the sum of a certain amount of numbers in a geometric sequence. So we're going to use the sequence that we did the first time for the geometric one, which is 10, 30, 90. And now we're asked to find the sum of the first 4 terms. So we write down what we know. We write down u sub 1 is 10, our common ratio is 3, and then our n now, which is what we're trying to find, is 4. It's 4 terms. And now our formula for that, what we stated in the beginning was u sub 1 times r times m, which is what we're finding, minus 1 over our common ratio minus 1. Now we plug in everything, and you should get 10 times 3 to the 4th minus 1 in parentheses divided by 2. Multiply the numerator out, and you get 800, and then divided by 2, which is 400. Okay, and there's also another way to solve this problem, and that's by using sigma notation. And now we would have to, so in your calculator there's a mode where you can figure out sigma, which is, it will just be an E like this, and then it will have like a blank space here and equals a blank space there. So this would be our starting term. We start at 1. It's our first term. Or you can start at 0, and then this could be 4, which is what you're trying to get to, or this could be 3, and this could be 1. I'm going to leave it as 3 and 1 in this case. So once you plug that in your calculator, you have to plug in this part right here, and you don't need to put that in, so you can take that out. And the 10 in this case would be your u sub 1, so it would be u sub 1 times your r to the power of n. And if you put that in your calculator, you should get 400. So it does all the math for you. You just plug in all the components of this, and you should get 400. Okay, so the last thing I talk about in this video, before I assign some practice problems, is finding the infinite sum for a geometric sequence. So in this case, we have to find the infinite sum of the sequence 1/2, 1/4, 1/8, and 1/16. So right now we have to write down what we know. We know u sub 1 is 1/2, and we know if we take our u sub 2 over u sub 1 and divide it by each other, you should get a half. So every time these are multiplied by half, so this times a half, times a half, times a half, and so on and so forth. And now, unless you want to add this up every single time, I wouldn't do it because it would take forever to do. And that's why there's a formula for it, which is S, which is the sum of infinity of the infinite numbers, equals the first term over 1 minus your common ratio. So now in this case, it's the sum of infinity equals 1/2 first term over 1 minus our common ratio, which is 1/2. And then if you simplify that out, it would be 1/2 over 1 minus a half, which is 1/2 again, which just equals 1. So the S, this infinite sum of this geometric sequence is 1, exactly 1. And now I'm going to show you some practice problems in the IB style format that you can do to practice these skills. Okay, so now I'm going to assign some practice problems to help you practice geometric and arithmetic sequences. So this is the first IB exam style question that I'm going to assign, which is the first 3 terms of an arithmetic sequence is u sub 1 is 5, 1, and 1.5. Okay, so for the first thing you have to do is find the common difference, then find the 10th term, and then find the sums of the first 10 terms. Okay, so for the last practice problem that I'm going to be assigning, it is a geometric sequence. So the question is, use the geometric sequence 3, 9, 27, and 81. And part A is find the 15th term. Part B is find the sum of the first 10 terms of the sequence. I will provide answers at the end of the video to check your work.